So we're going to now try and think about how we can actually use parametric equations for all of the previous things that we knew how to do as well. So this is going to be lots of things to do with points of intersection. We were interested in that with straight line graphs and curves. We now want to be interested in those things with parametric equations as well. So I've said here that we can find where a parametric curve crosses a particular axis or where curves cross each other. The key is to first find the value of the parameter t. Okay? It's going to be really important. T or theta is the thing that's happening in the background. We're going to constantly want to come out of the x and y world, and we're going to go back to the t or the theta world in order to then go back to the x and y world. This is going to be the important thing for how we do these Cartesian equations. Parametric equations. So what I've got here, it says the diagram shows a curve C with parametric equations x equals at squared plus t and y equals a t cubed plus 8, where t is a real number and a is a non-zero constant. Given that C passes through the point -4, 0, find the value of A. Okay, so if we have this coordinate -4, 0, what does this, going right back to basics, what does this actually tell me if the curve is going through -4, 0? Yeah, when y is equal to 0, x is equal to -4. Okay, when y is equal to 0, x is equal to -4. So I can use some of this information that might help me to be able to solve this equation. So I can say that when y is equal to 0, let's say that y is equal to 0, which means I've got 0 equals a t cubed plus 8. Now I can solve this equation to find out what t is. I don't want to know what t is as my final answer. I want to know what a is. But like I said at the top here, the key is to first find the value of t, because that's our little bridge that will take us between x and y. So when I solve this equation, what do I get as my solution? What is t going to be equal to? T is going to be equal to -2, because either a is equal to 0, but we know that a is not equal to 0 because it's told us that in the question, or we know that t cubed plus 8 is equal to 0. So t cubed is -8, which means that t is -2. Obviously, when you take the cube root of a negative number, it's a negative. It's not positive or negative. It is a negative number, because -2 times -2 times -2 is -8. So I knew that y was 0, and that told me that t was -2. So at this particular point here, t is -2. Remember how I said on the previous bit that you can't see what t is at particular points on the graph? You have to do some work to find out what it is. It's the thing that's in the background. Now we're going to say that x is equal to -4, and we know that t is equal to -2. So x is equal to -4, and t is equal to -2. So I'm going to go and use this bit here. So x is -4, and t is -2. So that's going to be a multiplied by -2 squared plus -2. So that's -4 equals 4a minus 2. And then I can add 2 to both sides and divide by 4. So that a is -1/2. Now what you might have been tempted to do, because of what exercise 8a and 8b has been about making Cartesian equations, you might have been tempted to try and make them Cartesian equations. But it would get really messy making this a Cartesian equation. And it's very elegant to just say, okay, let's find out what t is, then we'll find out the other bits that we need. So you kind of step out, you just stay in parametric. I don't want you to go to Cartesian unless the question says, put this in Cartesian form. Parametric is way, way, way more efficient. And then it says for part B of the question, find the coordinates of the points A and B where the curve crosses the y-axis. So I need to find this bit here and here. What's true when something crosses the y-axis? X equals 0. Okay, so for part B of the question, we now know that x is going to be equal to 0. So I'm going to go back to this equation that I've got here. and I'm going to try and find out some more information. So I get that 0 equals, well, a is minus a half. So it is minus a half t squared plus t. How many solutions will there be to that equation? 2. And those 2 are going to correspond to these 2 here. So I would factorize this. So that either gives me that t is equal to 0 or t is equal to t is either 0 or 2. So I can now use that information to find out what y is equal to. So we're constantly going back and forth between t, x, and y. So if t is equal to 0, y is equal to a t cubed plus 8. But remember, a is minus a half. T cubed is 0 cubed plus 8. So that's just going to be minus a half times 8, which is minus 4. And when t is equal to 2, y is minus a half, 2 cubed plus 8. So that's 2 cubed plus 8 is 8 plus 8, which is 16. 16 times minus a half is minus 8. So the coordinates for a and b, we know that the x coordinate is 0 and the y coordinate is minus 4. And we have 0 and minus 8. So I can add those to my diagram that I have 0 minus 4 and I have 0 minus 8. And I know that they're that way round just because of logically thinking about where they're crossing the axis, okay? I'm not quite finished with this. There's a couple more things I'd like to talk about here. Over this point, we said that t was minus 2. What's t for 0 minus 4? 0. Yeah, t is 0. That gives us the coordinate 0 minus 4. Whoops. Over here, t is 0. And for the last one that we had, t was 2. So where on the graph, roughly, is that t is minus 1? In between here and here, okay? It's a really obvious point to make, but sometimes people don't see this as a point, that this is where t would be minus 1. I don't know exactly where it would be, but it would be somewhere in between these things. And when t is equal to 1, it's going to be somewhere in between this section that we've got here. I might be interested in where this bump is at some point, but that's going to be something we'll look at in the future, okay? We'll try and say, I wonder where it has a maximum x coordinate and how you might think to find a maximum x coordinate, things like that, okay? So we're starting to see what I mean by parametrics and how we don't want to use Cartesian to answer these kinds of questions. Can I go on to the next bit? If people got that copy down? Any questions on this bit? On the why I've done these things?
You see when the curve crosses the y-axis?
Yeah.
Could you assume that one of the solutions would always be when t equals 0? Or would you still have to work that out?
When it crosses the y-axis. So I guess you could just say, you mean just to know that t was 0 from this? Yeah, you wouldn't have to show it explicitly like I did down here. You could just say this, and you could just say t is equal to 0. You could also put this quadratic into your equation solver, and you could just write down that t is 0 and t is 2. Because remember, you've got a quadratic equation solver that will always give you the solutions. And we knew there had to be 2 because of the fact it crossed in 2 places as well, okay?
For any question, one of the solutions be t equals 0?
No, no. It depends on the equation, because if this equation was at squared plus t plus 3, then t wouldn't be a solution for x being 0. It depends on the context. It just happened to be 0 in that particular one, okay? But thank you for clarifying that. So this is now going to be thinking about intersecting with a line. So this time we've got a curve which has been given parametrically by the equations x equals t squared and y equals 4t. And then they've got a line x plus y plus 4 equals 0 meets the curve at A. Find the coordinates of A. So we've got a curve and a line, and we want to find out where they cross. Just go back to like year 12 maths. A curve and a line, and you try and find out where they cross. What maths would you do? You would do simultaneous equations. And one of the techniques for simultaneous equations is substitution. So that's what we're actually going to do here. We're not going to create Cartesian and put them together. We're just going to stick in parametric, because parametric is a really efficient way of calculating things. So that's what I've written here. Whenever you want to solve a Cartesian equation and a pair of parametric equations simultaneously, just substitute the parametric ones into the Cartesian one. So this is a simultaneous equation, and we know with simultaneous equations that one of the techniques for solving them is substitution. And so we're going to solve this equation using substitution, and you'll see what it does. So we have x plus y plus 4 equals 0. So x plus y plus 4 equals 0. But I know that x is t squared, and I know that y is 4t. And so when I solve this equation, I'm not going to be finding out what x and y is. Again, I'm going to find out what t is. And this can factorize. What does this factorize to? Or you can use your calculators. So you get t plus 2 squared. So t is negative 2. But that's not the end of the question, because it doesn't say find the value of t. It wants you to find the coordinates of A. And remember, coordinates are x and y. So I'm going to use this information to say that x is the t coordinate squared, which is minus 2 squared, which is 4. And that y is 4 multiplied by t, which is minus 8. So the coordinates of A are 4 minus 8. When I have given this question to students in the past, a few weeks after we've done parametric, they have just decided to try and make this into Cartesian and to solve the equation. And it's so much messier. You can try it if you want to. But I want you to start thinking parametric is a really, really useful way of keeping things nice and simple. Did you have a question? No, okay. So I'm just going to quickly put this on on Desmos. So it's t squared and 4t. And it doesn't say what t is, but I'm just going to say that t can be. And the other equation was x plus y plus 4 equals 0. And we got that the coordinates where they intersected was at 4 minus 8. It's not quite coming up there, but you can see that it's 4 minus 8 where they cross. What else can you tell me about these two curves as well? It's a tangent as well, okay? And that's, what do you think in these calculations here has produced the fact that it's a tangent? There's only one value for t, okay? So we're starting to see how this is connecting up to lots of other areas of maths that we've done before as well, okay? So we have now got a different example here. We have got something not very pleasant looking for the x and y coordinates, and it wants us to find where the curve intersects the line. This does say y equals pi squared. Okay, that is meant to have a little 2 there. We want to find out where does this curve intersect the line y equals pi squared. Well, they're telling me something. They're telling me that y is pi squared, and I also know that y is this thing that I've got here. So I can just make them equal to each other. So that means that y, which is t minus pi over 6 squared, is equal to pi squared. Nice and easy to solve, actually, because I can just square root both sides. And then I can just add pi over 6 on, so that t is 7 pi over 6. Now, I need to find the point where the curve intersects the line y equals pi squared. So I need to find out what the x coordinate is. So I need to find cos of 7 pi over 6 plus sine of 7 pi over 6. And you know what, even though I probably could do these without a calculator, my brain's not in the mood to do it today. So make sure your calculator is in radians mode. And let's work out what cos of 7 pi over 6 plus sine of 7 pi over 6 is. You got what, sorry?
Minus 1.36.
Do you have that as an exact number?
Yeah. Minus 1 plus root 3 of b.
Minus 1 plus root 3, and that's all actually bracketed over 2 like this. Okay, so you could either say it like that, or you could have said it as minus 1 minus root 3 over 2. And what's the y coordinate? No calculation required. What's the y coordinate? Pi squared. Of course it's pi squared, because it's where it's crossing the line y equals pi squared. So the coordinate where it intersects will be minus 1 plus root 3 over 2 pi squared. And this is what a lot of answers are going to start looking like in year 13 maths. They're going to be weird looking. They're going to have surds. They're going to have pi. They're going to have all sorts of stuff. Okay. Now, I'm not sure I've given us quite enough space to be able to do part B, so you may want to write your next bit a little bit smaller. It says find the coordinates of the points A and B where the curve cuts the y-axis. Okay, where it cuts the y-axis, what do we know? X is 0 where it crosses the y-axis. So I'm going to look at this equation that I've got here, and I'm going to say that 0 equals cos t plus sine t. So it is a trig equation. How am I going to solve this trig equation? What have we done previously when we've had cos and sine together in trig equations? Pardon? Yeah, good. You're going to create tan from this. Okay, you're going to create tan. Just remind me, what is tan equal to? Sine over cos. So I'm going to divide everything here by cos, and that will create a tan. So 0 divided by cos is 0. Cos divided by cos is 1. Sine divided by cos is tan t. So minus 1 equals tan t. So t is the inverse tan of minus 1, which I do know, but I'm checking. Any guesses? Pardon? Yeah, minus 45, which is minus pi over 4. Okay, so it's minus pi over 4. Is that in the range?
No. Yeah.
Yes, it is in the range, isn't it? It is in the range minus pi over 4. What do you do with tan to find the next solution?
Plus 180.
Plus 180 or
2 pi.
no? 180 is pi. So instead of plussing on 180, you can plus pi to minus pi over 4. What happens if you plus pi to pi over 4? No calculator needed. 3 pi over 4. Why have I gone for 2 answers for t here? Because it's crossing at 2 points, and why else? It's in the range. There are 2 values of t that are in that range, and if I added on pi again to this, it would go outside the range. Would it? Yeah. Pardon? Well, I will put this in Desmos afterwards, okay? I'm going to make sure all of this goes in Desmos afterwards. So these are the 2 values of t, but that's not the end of the question, because the question wants to know where does it cross the y-axis. So you would now need to put these values of t in y to find out what y is. So I'm just going to do the page extender so I've got a bit more space. Sorry if you've run out of space in your booklets. So we know that y is going to be t minus pi over 6 squared. So that's going to be minus pi over 4 minus pi over 6 all squared. So that's minus 5 over 12 pi. Don't put the pi in there when you square it, because your calculator won't be able to tell you pi squared, okay? So minus a quarter minus a sixth is minus 5/12 pi. Don't put that in your calculator, just put the 5/12 squared. And 5/12 squared is 25 over 144 pi squared. And then for this second solution, it would be 3 pi over 4 minus pi over 6, all squared. So we'll do 3 over 4 minus 1 over 6. So it's 7 over 12 pi, all squared. We don't even need the calculator because 7 squared is 49 and 12 squared is 144. So the coordinates of A and B where it crosses the y-axis, well, we don't know which one is A and which one is B, and it doesn't matter. I'm just going to kind of put it in on this section we've got here. So A is going to be x is 0, and y is 25 over 144 pi squared. And B is 0, 49 over 144 pi squared. Does it feel demanding? Yes. A lot of the things that feel demanding about this is that you are pulling on several different areas of maths at the same time. Here we have pulled on quadratics, we've pulled on surds, we've got trig equations. We had to remember that tan you add on 180 or pi each time. We had to know coordinate geometry about where it's crossing the axes. There's a lot of stuff that you have to know. So I'm not surprised that we're saying it's demanding. And Muhin, you wanted to put this on Desmos, and I agree. So we're going to do cos t sine pi over t. And the y part was t minus pi over 6 squared. Oh, yeah, thank you. Whoops. And t is between minus pi over 2. Is it 4 pi over 3? And we wanted to first of all find out where it crossed the line y equals pi squared. Okay, so here is the curve in question, which is a very, very strange looking curve. It crosses up here, which is minus 1.38, 9.87, which I'm hoping is what this x coordinate is. Yeah, I think you said it was minus 1.36 when you put it in the calculator. Yeah, and that's what the x coordinate is, and the y coordinate is pi squared, because 9.87 is roughly pi squared. And then the other thing we wanted to work out is where does it cut the y-axis. So one of the places is down here, which looks like, for some reason it can't tell us what this is. X is 0, so 25 over 144 pi squared. Let me just quickly work that out. 1.71. Yep, so there it's crossing at about 1.71. And then the other one was 49 over 144 times pi squared, which is 3.35, which is there, which is 3.35. So that's kind of what it looks like in graphs. And if you tried to do this using Cartesian, you'd get pretty stuck with this. Okay. So I'd like you to... We will have a go at this one later, okay? But there is an exam question here that we can do. We're going to do some questions from exercise 8D now, okay?